All right, just going to do a wee quick demonstration here of the HPC method. And this first wee video tutorial will just give you some sort of an idea of what the dumpy level is able to do, really what's meant by the height of plane of collimation, how we work really from a temporary benchmark, or what's referred to really as a TBM, and how we take a backsight to that TBM, and then how really when then you know the height of the level, which can be worked out using that TBM, how you can then use that information later on then to work out the height of various other points. In this wee demonstration again, you might feel it useful to perhaps pause the screen and do a wee quick sketch on a piece of paper, screenshot this perhaps, and print it off to give you some sort of an idea in relation to what's going on. Now, this top diagram here is a plan elevation, and for some people again maybe used to using technology in design or construction, that just basically means you're looking down really from the sky like a bird's eye view, so to speak. So on this, I suppose, hypothetical construction site, we've got these wee concrete platforms. The first platform here on the left-hand side is really your temporary benchmark. So we would know that level. It's given to us in a particular project. We've set up our dumpy level here. You can see in between the TBM and station point 1. And then finally, we've got another wee concrete panel here, or wee sort of pillar, and that's station point 2 on our side elevation here. That's us basically getting down on the ground, almost hunkering down, and then you can see the concrete platforms. You can see what height they're coming up really relative to the ground as well. So if you feel it to be useful, you could pause the screen and just take a wee quick sketch, or indeed again screenshot that and print it off. Now, the first thing we're going to do really is to figure out what height the level is currently at. All right, so of course, you'll have got some experience how to level up the actual dumpy level using the legs, plus of course the wee 3 screws to make sure the wee bubble is inside the circle. And of course, the more accurate that bubble is inside the circle, the closer it is to being dead center, the more accurate, of course, your survey will be, and less likely to sort of fall outside tolerances when you're doing checks and whatnot. I think that when you sort of get this visually, it is pretty obvious that the height, by the height of the level, we're going to the very, very center of the level. So it's the center of the scope that you're going to look through. To get that specific height, now it's called the height of plane of collimation. And we shorten that down to HPC, and it's the HPC method we're going to deal with in this wee video tutorial. To get that height, you literally have to go back onto your TBM, and I've made the numbers quite easy here, just saying, look, the TBM is 100 meters AOD above ordnance datum. It might be above sea level, for instance. And if we could somehow get a measurement here of what's the height from the top of the TBM to the center of our level, then if we add those two together, that's going to get us the height of the actual instrument itself. When we sort of figured that out, then we can then hopefully use that information to figure out, well, what's the height of station point 1 and the height of station point 2 as well. Now, before we sort of undertake this survey, I've made these heights quite different, so the difference should hopefully be quite obvious. So if I was to take, a straight line here from the top of this platform and run it across, you can see quite easily there, like the station point 1 is lower down than the TBM, so we'd expect at the very end that the height of this here, which is recall like a reduced level, is going to be less than 100 meters. And finally, station point 2, you can see the height of it is above 100 meters. So I'd expect this reduced level to be indeed above 100 meters as well. So if you're ready, we'll hop in here to our first step here, where we're going to really take a backsight onto our TBM, and we can use that later on then really to try and figure out what the height of the instrument is. All right. Now I'm just going to do a bit of hopefully split screen here, and then put up a wee Microsoft Excel file, and then really show you how we book this data on our standard wee surveying sheet. And this is set up for the HPC method. Now you can see that this person undertaking the survey has gone back across onto the concrete plinth where our TBM is. They've got another operative on site, a labourer or whatnot, or an apprentice surveyor to hold the staff, and of course make sure it's straight and moving it backwards and forwards to get the minimum measurement. Now, because we're having to sort of swing back, we're going back to a TBM, we're going back to a known height. We refer to this first measurement as a backsight, and that's abbreviated really in your wee surveying sheet as BS. Now I'm going to record that down. I imagine I'm out on site. I'm the person standing behind the dumpy level here. I have taken, maybe checked that twice, and I'm happy that it ends up on my staff being 0.908 meters. We'll just type that in, 0.908. So of course, if you're out on site, you'll be using a pencil and you'll be logging this in a wee surveying maybe book if you're lucky to have one of them, or just a wee sheet that's printed off maybe. It's been produced in Microsoft Excel. All right. Now I'm only going to fill in the information here first of all that we have gathered the raw data from our survey, and then we're going to take a hypothetical journey into the construction office, and then we'll see what calculations we can undertake to work out the reduced levels of ST1 and ST2 as well. So at the moment, you've got back onto your TBM, you've got your backsight, and again, you'd always double check that. Always just maybe log that down in your book, and then maybe just take a wee check again, like, and then just satisfy yourself that you haven't made a mistake, maybe and write down, 980 instead of 908. It can happen, and you're going to be out there quite significantly. Now, after you've done that, our second step is to really then go and try and work out what the height is to ST1. Now, unless we're going to change the position of the instrument, I could take 100 measurements now with the level in its current position. So you might imagine, for instance, maybe you've set up your dumpy level in the middle of a basketball court, and you now know what the height of that level is. You could literally take dozens of measurements about the entire basketball court without having to move the dumpy level. And similar to like our soccer pitch or rugby pitch as well. Now, all these intermediate measurements we're taking are referred to as intermediate sites, and in this case, IS. All right, so intermediate sites, and you can see my first measurement here I have worked out here is 1.134 meters. So if I go to my intermediate site here, and just a note, come back on the previous one, whenever I was logging this in, I was going back to my TBM, and so the BS is filled in on the same row on my booking sheet. Because I'm now going and taking measurement to ST1, I need to be using this row ST1 in my booking sheet. And because we're not changing the position of the level or whatnot, again, I call this an intermediate site. So I'm just going to book that in here. Again, critical. We're currently going on to ST1. So just put in that measurement there, which is 1.134 meters. Again, even though I'm typing this in, just a wee quick check to make sure you haven't made a mistake. And 1.134 does look to be okay. Now, without doing anything more, again, the level's perfectly fine. As long as this ST2 is within, roughly 40, 50 meters, that's perfectly fine if your level is well calibrated. We can now literally get the fella, the staff, to move out to ST2. All right, you haven't moved anything. And because, again, you're not going to change the position of the instrument, again, this is, again, an intermediate site. So I would just, again, be careful, check your staff and whatnot. Now, again, we are currently taking a reading based on ST2. So we need to be using the row, ST2 in your booking sheet. And because, again, this is an intermediate site, you put it in the intermediate site column in your booking sheet. So if you then put in 0.682, again, if I was out on site, I wouldn't be telling the fella and the staff to go on ahead. I would be stopping, take a breather, get him to do that again, and just double check that you've booked that correct, because one mistake here, if you're out working on a construction site, one small mistake here could cost thousands, if not tens of thousands of pounds. So it's a small price to pay, taking those extra few minutes if needs be to double check these calculations. So 0.682, yeah, that seems okay. Now I know, of course, that this is a very small scale survey. We've double checked each of these measurements, and I'm now literally going to just go back up to my construction office and just take a wee quick check to make sure that everything looks okay, and do some measurements. So at this stage, you can go up. If you're lucky, you can stick the kettle on, maybe get a drop of tea or a drop of coffee or whatnot. And we're now going to sort of try and figure out here, how do I get the height of plane of collimation? And then perhaps how can I use that then to work out the reduced levels? We want to ultimately know the reduced levels of ST1 and ST2. All right, that's the critical piece of information we want here. Now, just again to re-emphasize, hopefully again you perhaps copied out the first diagrams, but if I go up here again, like I think it's pretty obvious from that first diagram there, that my height of plane of collimation, the height of this blue line, is going to be quite simply my TBM of 100 meters, and then add on this measurement. So I think, when you can see it there in diagram form, it doesn't really lead to any confusion. So my HPC, the height of my instrument, is based on my TBM height, and I'm going to have to add on my backsight. So the height of my instrument here, I'm just going to fill this in yellow. You don't, of course, do this in real life, but the yellow is just the measurements you're completing in the construction office, which can be differentiated from your raw data that you've gathered in out on a construction site. Might be useful, look, after you've taken your raw data, like maybe use company policy just to back that up, maybe take a photocopy or a picture or whatnot. And of course, there are checks to do, which we're not going to talk about in this wee sample video here. Now, if I sort of just zoom on down, I think it is important if you can visualize what's going on. Because whenever we go now across to step 2 here, if I now know that the height of my instrument is 100.908 meters, that's the height above sea level, for instance, for the center line of my instrument. Well, to get the height of this station point 1, surely if I take this height and then take away this dimension here, this height here, this intermediate site, that's going to give me the level of ST1. And it's as simple as that. So if I go into Microsoft Excel again here, my reduced level for station point 1 is going to be quite simply equal to this height, and I'm taking away this intermediate site here, giving me 99.774. And in a similar sort of fashion, if I flick back into my CAD drawing here, and if I look towards step 2, if I again understand my level hasn't moved, it's still the height of 100.908 meters. And if I know the height of my level, surely if I take that height of my level and I take away this intermediate site reading, that's going to give me the height of ST2. It's really this height. This is how much you're above sea level. I'm going to have to take this much away again. And if I go back into Excel again, this reduced level is going to be equal to my HPC, and I'm taking away this intermediate site, which you can see is giving me 100.226. There is no ST3 here, but you could, of course, continue this process as much as you need for whatever number of points are on your construction site. Now, just one wee quick thing again, like it's important to perhaps zoom out if needs be, and just take a wee quick check and ask yourself, look, does this make sense? So station point 1 here you can see is 99.774. And if I go back into my CAD drawing and just take a wee check, we talked about at the very start that this one was definitely lower down than the initial concrete platform. So that being less than 100 does make sense. And we talked about, of course, that ST2 is well above the 100. So the fact that we're getting it, 100.226 again makes sense. So always just again, particularly when you're getting used to these processes, take a wee quick check and just make sure you haven't made any unforeseen errors. You'll know if you're wrong, because if you're going uphill, for instance, you'll be expecting, of course, the reduced levels to increase. But if you're going downhill from the TBM, you will be expecting your reduced levels to be decreasing. And that's the first part of this tutorial for HPC. And the next one, we'll look at what you have to do when you reach a change point, which perhaps complicates things a little bit.